do that one in your notes here. See if we can get this set up, and go ahead and type it into your calculator and get the answer. Awesome. Probably get all 4 views on my YouTube channel. All right. So we got somebody in the other class was asking where I get these problems from, and I'm like, well, yeah, I'm sure I'm violating both copyright laws and everything else. And then to make it even worse, I'm publishing it out on YouTube too. So whatever. What are they gonna do? Fire me? All right. So we rotate this around. Y equals -1. Like so, and so your radius comes from the center, so you got empty space in here, so it's a washer. We got big R, we got little r, right? Outer radius and inner radius. And so big R would be this Y value, -x + 1 minus -1, and this will be 0 minus -1. And so we get our big R and we get our little r here and here. And so pi, big R squared, little r squared, and then the strips fill the space from 0 to 1, and so there it is. Now, like I said, it was a no calculator problem, actually, where the AP test I took this from, and so you would have to FOIL this out, which would be x squared, inner would be -2x, -2x would be -4x, 2 squared is 4, and then -1, which would make 3. So antiderivative of that would be 1/3 x cubed. Antiderivative of that is 2x squared. Antiderivative of 3 is 3x. Put a 1 in there, 1/3, take away 2 plus 3. Put a 0 in. Of course, it's all 0. So -2 plus 3 is 1. 1 and 1/3 is 4/3 times pi. So you get E. Okay? But for our quiz next week, type it in on your calculator. Now, you have to draw a picture. You'll get points for your sketch. You'll get points for your problem setup. You'll get points for your answer. Okay, so that's just a basic run-of-the-mill washer. They give you the graph, they give you the region, revolve it, just a washer problem. So there'll be a fair amount of that on the quiz, you know, just the basics of doing these volume problems. But there could be some missing pieces, some things you have to do in addition to, and so we want to look at a couple situations like that. So here's one. It says a solid has a circular base of radius 3, so they don't give you the equation. So what you need to do is draw a picture. I would put it at the origin, would be the easiest, and you're going to have to know the equation of a circle. So you're going to have to write the equation of the circle and then go from there. So one little extra step you have to do. If every plane, if every cross section is perpendicular to the x-axis is an equilateral triangle, find the volume. So again, it's one of our basic slices we're doing. So go ahead and give that one a try here. What do we got? E. E is the one we're looking for. So we got x squared plus y squared equals 9. So we have to solve that for y because we got vertical strips. It's perpendicular to the x-axis. So it's up and down, and so we got plus or minus square root of 9 minus x squared, top half, bottom half. So this strip is the base of an equilateral triangle that's coming up off of your page. So coming up off of here are equilateral triangles, and so this is one side of the equilateral triangle. So our formula is root 3 over 4 times the side squared. I call it the base here, but then you take your top y value minus your bottom y value. You cannot square root 9 minus x squared and get 3 minus x, so don't try. Can't do it, okay? So do not square root this and think that's 3 minus x. It doesn't work, okay? So you got that, so you get this minus a negative that makes 2 of those. So you got 2 of those squared. So root 3 over 4 times your base squared is your equilateral triangle, and the strips fill the space from -3 to 3, and that gives you 36 root 3. Okay? And again, so that one was just, again, really a basic one, other than they didn't give you this. You had to make that up, make that equation up on your own. If that had been given to you, then it would have been, again, just a basic one, which is a big part of, a big chunk of what our quiz is. Now, our quiz has also got some other Chapter 7 stuff in it too, areas, and some stuff we have yet to learn too. So there's other things in there. All right, last one today, and then we'll get into our new thing. So we have a region R enclosed by the coordinate axis and the graph of this parabola, but there's this unknown k value here. And so we're talking about this region right here, okay? When this region is revolved around the y-axis, okay, the solid formed has a volume of 8 pi cubic inches. So we sometimes freak out a little bit. We see that K in there. We do the same thing we would normally do. We set it up. But this time we know the volume is equal to 8 pi. So therefore, this is a calculator one. Actually, the last one was a calculator one too. This is a calculator one which you can solve. You can do a solve on your calculator. So you set up your integral for your volume, set that equal to 8 pi, and then you can, on your calculator, solve for K. Okay? Give this one. What direction are the strips going to have to go on this one? Horizontal, right? Whenever you've got a axis of revolution that's like this, right? If your axis of revolution is here, your strips have to go this way, right? So this has to be a horizontal strip scenario. Okay? All right. Go ahead and give that a try. All right, so since you have horizontal strips, you have to do what with this equation? You have to solve for x, right? So what do you got for that? You got x equals what? Square root of y over k plus 2. Anybody disagree with that? square root of y over k plus 2. Anybody disagree? I disagree. Here's why I disagree. You're really close. Which part of the parabola are we looking at here? When you do the square root of y over k, you got to remember to do what? Plus or minus. What's the plus for? The right half. What's the negative for? Left half. So when you solve for x, this is the left half of the parabola. So you have to have negative square root of y over k plus 2. Negative y over k plus 2. So that is, well,
the whole square root negative or the inside square root?
Outside the square root. Outside the square root. Negative square root of y over k plus 2. Okay, so there are several tricky parts of this, but that is probably the trickiest part of that. So if you had gotten that far, gotten the x by itself, and done all that, then you were probably in really good shape until if you didn't have that negative, of course, that's going to throw you off. What did you get? Did you guys try to solve it then? Did you get far enough to solve it yet? There's another tricky part to it. Well, let's just go through it. Okay, so let's talk about it one piece at a time. So here we're going to try to get the x by itself. So we're going to divide the k over there. Then we're going to square root it. We get a plus or minus. X minus 2. Then we're going to add the 2. I just wrote the 2 on that side. Doesn't matter. But we're going to want the negative square root. Okay? Because it's the left half of the parabola, right? You got top half, bottom half of circles. On a parabola, you got the right half, left half if you're doing that when you square root it. Okay? So that is that. Now when we revolve this, do we have any empty space? No empty space. So we revolve this. We're just going to have a plain old disk. So that blue strip is a radius. So we take our right x coordinate, which is this, minus our left x coordinate, which is 0. So here's our radius. So we got pi times the radius squared times the thickness, and then that's got to equal 8 pi. But then we got to do the strips. The strips fill the space from where? From 0 to what? Well, this y value right here. How do you get that y value? Plug in a 0 for x, because this point right here is 0 something, and so you put a 0 in for x right here. So you put a 0 right here, or you can put it in over here, but it'd be easier here. Put a 0 right here, 0 minus 2 is negative 2, square that's 4, 4 times k. So when x is 0, this y value is 4k. So the strips are going to fill the space from 0 to 4k. And so you type this into your calculator as a solved problem. Now, actually what I did is I just typed this integral in, and it gave me 8 pi k over 3. And then I just solved, then I set that equal to 8 pi, and then it was easy to get k equals 3. But you could just do a solve. Solve this for k. Right? So, little different twist, but if you think about the steps, they're no different than any steps we ever do. We got a horizontal strip, we got to get the x by itself. You have to get that thing with the negative, the left half of the parabola, so that's a little tricky, but you got to do that. Then you got pi r squared, you got the strips fill the space from where to where, and then set equal 8 pi and do a solve. So, like I said, little different variation, but understand what's wrong. So there could be some things like that on the quiz as well. Okay, so we want to be able to set those up and do that. Again, have problems with these volume problems, I'm here every morning, bright and early. Love to help you out if you got questions. All right, so let's move along today. And so in our notes now, you don't need to write this out. It's totally up to you because this is stuff we've already put in our notes. All this stuff that's on here is already in your notes, okay, on our volumes. It's just the 5 different slices. Types of slicing, but today we're going to learn an alternate method of doing a volume. Okay, and you'll see why here, why it might be nice to have an alternate method. Now, in the AP test, they give you problems. So on our finals, they're going to give you problems that can mostly easily be done with the disc washer slicing kind of method. So that's what you'll usually see in the packets and all that stuff. And on our finals. On the quiz next week, though, I may give you some where I say I want you to use this alternate method we're talking about, or I may not. I may just give you some problems that are more easily done with this alternative method. So it could go either way. I might tell you you have to use, it's called the shell method. I might tell you you have to do one with the shell method, right? Yeah, that'll be in the instructions. Or it just might be that it would be easier to do it the shell method. You would maybe choose to do that. So you got to be prepared to be able to do it. So let's talk about what the shell method is. Well, first of all, we've got our method of volumes by slicing. Yes?
It's a shell because you use shells.
Well,
you're a guy named Shell.
No, it's not a guy. It's shells. Yeah. whatever a shell is. I don't actually like to call it shell method. I mean, that's what it's called, but I'll talk about, that's why I say by wrapping. We'll get into that, okay? So, but first of all, by slicing. So the way we did this slicing with the lemons, right? We sliced 6 slices, we added up the volumes, and we said, what about 100, what about 1,000,000, what about infinite number of slices, right? And so our slices were the area of the slice times the thickness of the slice, and of course the thickness went down to nothing, and that became the dx, and that gave us the volume of the slices. So you could have slices of these 5 different types. Now, there's 2 different types of volume problems that we've seen. We've had our revolution problems. The revolution problems are the ones that are either going to make circles or washers. If there's empty space, it'll be a washer. If there's no empty space, it's just a solid circle. And those are our revolution problems. So this new method we're going to learn is an alternate version for the revolution problems. Okay? It's only good for the revolution problems. The solids that are on a base, the squares, the equilateral triangles, the semicircles, there is no alternate method for those. And that's why I've got this kind of shaded out over here. There is no alternate method for the solids on a base. You just do them by slices, and you do them the way we've been doing it. Okay? So if you have a problem where you're taking a region and revolving it, we're going to look at an alternate way of doing it. So now let's say we were doing our lab again, our lemon lab. But this time, instead of lemons, I want us to think of onions. Now, that would be an awful lab to do, so that's why we're not going to do it. But let's imagine we were doing the volume of an onion. Okay? Now, one way to find the volume would be just like with the lemon. We slice 6 slices, and we find the volume of each slice, and we add it up. We could do that. But we could also think of it this way. What if we could take that onion and peel off an outer layer? And then peel off another outer layer. And then peel off another outer layer, and then peel off another, and then another, and then another, until we got down to nothing, to the very inside. And it doesn't make sense that we could add up the volume of each of those layers. Now, each of those layers could be very thin. They could be thicker too, right? And again, same thing. We could peel off it in 7 layers. We could peel it off in 100 layers. We could, right? We could go down to an infinite number of layers. So when we talk about volumes by wrapping, think of it in reverse. You create an onion by an inner layer, and then another layer, you wrap another layer around it, wrap another layer, wrap another layer, wrap another layer. If you add up the volume, and the integral is the adder, if we add up all the layers, the volumes of all the layers, that should also give us the volume. Well, they call those shells, I guess. Shell, the old shell game where you got, well, that's different, but you can have shells inside of shells, and they use shells. I don't know why they name shells, but that's what it's typically called in all the books, okay? But I like to call it by layers, right? Think of it as layers too. All right. So we're going to come up with the formula for that. So it would look something like this. If we had a region here, and let's go to this one. No, not that one. Let's go to this one. Okay, so if we had a problem something like this, and we were going to revolve this around this vertical axis, okay? I tell you what, before we do that, matter of fact, let's move it. Oops, let's move our axis over here. Before we do that, let's actually do a problem where that's similar to the one we were just looking at, but with the method we know about right now. So let's go ahead and do this problem. I wouldn't put this under shell method. We're gonna get to the formula for the new method here in a minute. But here would be square root of x, right? Be your sideways problem. So let's do this problem together. Okay. So you've got square root of x. Bounded by x equals 1, which would be like right here. X equals 4, which would be over here. So we'd be looking at this region right here. And we're going to revolve that around x equals 5. Okay? So this could be a problem that I would give you on the quiz next week and just say find the volume. I might tell you use a certain method, or I might not. I might just say, you just, more than likely, I'll just say find the volume. Okay? So, What's the first thought that comes to mind as you want to attack this problem? Washing. There's going to be empty space, right? Okay, I agree. What else? Horizontal strips, right? Horizontal strips. Because whenever you have an axis of revolution vertical, your strips have to be perpendicular to them. Okay? Horizontal strips. What else do you notice on this one? Okay? So what are you going to have to do? You mean like here? Yeah, it'd be good to know these points. So let's see, what's this one? 4, 4, 2, and what's this one? 1, 1. Okay, what else? Notice I haven't drawn any horizontal strips yet. No. But why haven't I drawn any strips? What's the problem on this one? Not really a problem, but added work. Huh? Well, no. I mean, yeah, you will, but I mean.
With horizontal strips, it doesn't ever contact the line.
So you have to do what? You have to separate this into two problems. We're going to have to separate this into two, right here. Because the strips on this part, the strips here are going to touch this curve on the left and this on the right, and the strips up here are going to touch the parabola. You got to split this into two. You have no choice. You have no choice. Okay? Now, we haven't done a lot of those. We've done some of those, but we haven't done a lot of those. When we were doing areas, that's when we said, well, geez, this would have been a better area to do with vertical strips, right? Because horizontal strips, you got to cut into two. Here we got no choice. When the axis of revolution is vertical, our slices have to be perpendicular to that. We have to do horizontal strips here. Aha, unless we learn a new method. And that's the new method today. Will allow us to not do horizontal strips, but we'll get to that in a minute. So, now, and there's empty space, right? So I'm going to need a big R and a little r. So here, down here, here's my big R, here's my little r, right here. Up here, my big R is there, and my little r is there. Actually, the same as the little r on that one. Okay? So I have to split this. Let me use a different color here. So I have to split this in two right here at the black line. You got to recognize that, right? That's one of the reasons we're reviewing this. However, now that we're going to learn this new technique, you might be able to avoid this. That's one good reason to have it, okay? So even on the AP test, on our final, you're not going to be required to do the shell method on any. It's possible that one of the problems might be easier done with the shell method. So you'll have that available if you want to use it. Okay, so let's do the top part first. So let's do the top part first. What's big R on the top part? What's big R on the top part? Right minus left. 5 minus, aha, very good, y squared. Yes, you got to solve this for x. Horizontal strips, you got to solve that for x. That's going to be x equals y squared. So we got 5 minus y squared. What's little r? 5 minus 4, which is 1. So we get pi, oops, it's not a pi. Pi, and the integral is going to go from what to what? 1 to 2. 1 to 2, right? And then pi, and this will be big R squared minus little r squared, right? And I think that comes out 103 pi over 15, if I remember what the other class said. Now I don't really care about typing it in right now. Hopefully we can all do that. But if we can't get set up, it doesn't matter how good you are at typing it into your calculator. Okay, what about the bottom? What's big R? 5 minus 1, which is 4. Oh yeah, that bottom part's just going to be a cylindrical shape, isn't it, with some empty space in it. But let's just go ahead and do it. I mean, we could do some geometry actually on that, but why bother? It's just as fast to just do this. 5 minus 4 would be 1, would be little r. So this is going to be pi from what to what? 0 to 1, 0 to 1 up to the black there. And then that's going to be pi, and that's going to be big R squared minus little r squared, right? Like that. And that's 15 pi, I believe. And so altogether that adds up to 328 pi over 15, I think is what the other class had, if I remember right. Okay? So that's how you would have to do that. And if you choose to do that, that's fine. You say, you know what? I don't want to learn the shell method. I don't want to do that. Not good. I'm a senior. You can't make it. Okay? So you want to do that? That's fine. You can do it this way. Okay? Unless, of course, you said, I don't want to do volumes at all. I'm not doing it. Okay. Whatever. 328 pi over 15.
Can you always use your shell method?
No. That's a great question. And to be honest, you can't, okay, in theory, you could always use dishwasher. In theory. But it's pretty tricky. Here's the key. Here's why this alternate method is going to work. Because the alternate method, if dishwasher requires horizontal strips, this new method, you'll see why in a little bit, is going to be vertical strips. They'll be opposite. If dishwasher requires vertical strips, then this new method will require horizontal strips. Sometimes, and to be honest, vertical strips are usually the ones that are nicer. Why are vertical strips? What do we have to do on horizontal strips that we don't have to do usually on vertical strips? Change the equation. Usually our equations are y equals. Now, here's where horizontal strips would be no good. If you had an equation that was y equals x cubed minus 3x squared plus 7, it is impossible, at least in a nice closed form way, to solve that for x. You just can't do it. Now, there are some tricks and some things you can do, but we're not going to get into that. So in theory, you could do something with it, but this new method is going to be much better. So in an equation like that, vertical strips would be much better. But remember, when you have what determines your strips is your axis of revolution. If you have an axis of revolution that's vertical, your slices have got to be perpendicular. So you've got to do horizontal strips. Well, if the equation will not allow you to get x by itself, you can't use horizontal strips. So this new method, the wrapping, is going to be like this. So the strips are going to be vertical when you have an axis of revolution like this. If the axis of revolution is like this, slices have to be this way. Wrapping is this way. So whichever strips are easiest would be the method you want. Okay, so in a sense, for what we know, I would say the answer to your question is, yes, there are times where shell method just won't work, and there are times where dishwasher just won't work. Now, in the AP test, they're just not going to give you any of those where dishwasher won't work, right? So for the AP test, it's always going to work. But for our quiz next week, I might give you one of those because I'm wanting you to maybe show that you can do the shell method. Okay, I might give you one of those. Or I might just give you one where you can do it either way. Some people in past years have worked it both ways. If it's a pretty easy one, we'll do one of those. Where it's pretty easy to do it both ways. So you try both ways and just double check, see if you get the same answer. That's what we're going to do on this one here in a minute. Okay? All right, so let's talk about the shell method. So this would be the solid that we would be looking at. If we took this region and revolved it around an x-axis or an axis of revolution over here, we'd be looking at a solid that looks something like this. But notice I have a vertical strip there, not a horizontal strip. So the solid, you can see the solid. You can see the solid just fine, but what we don't have are washers in there. We don't have slices in there. What we have is what they call a shed. And so and I would call it a layer, okay? And if you look through here, those would be the layers, okay? And they're cylindrical shaped. Sometimes this is called the method of cylindrical sheds. It's a cylinder-shaped layer, okay? And so here we have, and what we'd be doing is adding those up, okay? Or think of it like this, okay? Adding up those layers. Now, another nice thing about the shell method is the empty space doesn't matter. The empty space is going to get taken care of when we set up the problem. So we don't have to do one thing for empty space and one thing when there's not empty space. It's not going to be an issue. Okay? All right. So here's the idea. The idea is that when we have a vertical axis of revolution, our slices have to be this way. And what that creates is, as we've seen, a disk or a pi r squared slice. Or we've also seen scenarios where we have empty space. We have empty space, and when we revolve it, it creates a washer. Okay, so we've seen those two scenarios. So what we're talking about now is we're talking about making that strip parallel to the axis of revolution, and we're talking about creating a layer. And what we're going to do is we're going to have little layers in here, and then bigger and bigger and bigger layers, just like you saw in that other picture. And we're going to add up the volume of each of those layers. So our job is going to be to write the volume of this shape right here. Now, what shape is that? It's a cylinder. Well, it's a cylinder inside of a cylinder, right? What's the area of a ring, a washer? How did we do that? We did pi big R squared minus pi little r squared. We did the outer area minus the inner area. That's how we get the area of the ring. Well, now we want the volume of a shape like that. Well, what are you going to do? The outer cylinder, which will be pi r squared. No. What's the volume of the cylinder? Pi r squared h. So pi r squared h would be the volume of your outer cylinder minus, since it's outer, we'd be pi big R squared h minus pi little r squared h, right? We don't want the empty space in here. We're trying to find the volume of the solid, the blue part, right? We're trying to find the volume of that. So it'll be pi big R squared h minus pi little r squared h. That will be the volume of one layer. Now, what's going to get thinner and thinner on this? What part of this? This part here, right? The layers are going to get thinner and thinner. For example, here is a picture of what we were just talking about. That would be one layer, right? That would be one shell, what they call a shell, right? Here would be 5 of them, right? Here would be 5 of them. Kind of like we did 6 slices of a lemon. They have a thickness to them. But what we want to get to, let me move this so it looks like that one we just did there. What we want to get to is this, right? What we want to get to is where they're really thin. And infinite number of layers. And we add them up. Okay, so our goal then is to, now you don't have to write this part out until we get the final answer, it'll be fine. But what we want is the volume of one of these shells. Well, this is going to be our height. And we said we're going to have big R, which will be out to here. We're going to have little r, which will be right there. And so this is going to be pi big R squared h. So let me write that over here, actually. So we're going to have pi big R squared h minus pi little r squared h. And that's going to be the volume of this cylinder-shaped layer. Okay? Now, what's the part? Remember, when we do an integral, though, we always got that part that's got to go down to nothing. Right? We got the part that's got to go down to nothing. Well, that's this part right here. Now, remember, when we were doing the lemon slices, we said, well, those lemon slices are cylinders. That's pi r squared h. Which part of that went down to nothing? What part of pi r squared h went down to nothing? The h, right? And so we ended up with pi r squared and then dx, and that's how we came up with our formulas for the slicing. Okay, that was easy. The h went down to became the dx. Well, is the h going to go down to nothing on this? No. The part that's going to go down to nothing when we get infinite and thinner slices is going to be this right here. And did we even give that a name? Does that even have a name right here? The part that's going to go down to nothing? It'd be big R minus little r, right? We don't even give it a name. So I need to rewrite this. I need to rewrite this so I can give that piece a name. Okay, so here's what we're going to do instead. We're going to call this piece, let me change colors here. We're going to call this width right here, we're going to call that W. Okay, we're going to call that W. That's the part that's going to go away. That's the part that's going to get thinner and thinner and thinner. Okay, and then we're going to call P the distance from the center to the middle of that strip. Now again, the middle of that strip will just go down to nothing, right? The strip's going down to nothing. So it's basically the distance. Okay, so P is going to be, I'm going to write that, now we'll write that down, we'll write this down again when we do our formula here in a minute. But P is going to be the distance from the center to the strip, right? Because this is our strip right here. This is our, H is our strip. And H, of course, we can tell is going to be the length of our strip. That's what we've been doing anyway. That's what we've been doing in all these problems. We've been doing length of the strip. So H is going to be the length of our strip, and P is going to be the distance from the center out to the strip. Now let's see about this W. Okay, so let's make a substitution here. So instead of big R, what can I call big R? What would big R be in this, the way I've set it up now? What would be another name for big R? No, I don't want to use R. You're right, it'd be little r plus W, but I don't want to use R. I want to get R's out of there. I want to use these two new ones that I've made. P plus 1/2 W, right? Because we said P was going to go to the middle of the strip there. Okay, the middle of the strip right there. So P plus 1/2 W would be big R. What would be little r? P minus 1/2 W, right? So now we can replace big R and little r in our formula with those two things. And so now that'll, because what I needed to do, listen, the whole reason I'm doing this is I need to get W involved. I need to get W involved because I need W to shrink down to nothing. That's why I'm doing it this way. Okay, so let's make a substitution here. So we're going to go pi, and in place of big R squared, we're going to go P. This is a part you're never going to have to do again, so you don't have to write it if you don't want. And then pi, and then little r is going to be P minus 1/2 W squared, and then H, right? Like so. All right. That is not supposed to be P. That's supposed to be pi. But pi starts with a P, so it's close. All right. So, don't. All right. So, let's factor out the pi and the H just to make life a little easier on us. Okay, well, so we'll factor out the pi and the H on each one of those. And now let's FOIL those out. Okay, so let's FOIL this one out. What do we get? P squared. What do we get there? How much? WP, PW, right? 1/2 PW plus 1/2 PW would be 1 PW, outers and inners, plus 1/4 W squared. Okay, now we got a minus, so we got to remember when we do this FOIL, we got to do the opposite on each one. So first, minus P squared, inners, outers, negative PW, right? Which would turn to a plus PW, right? But it's negative 1/2 PW, negative 1/2 PW would be negative 1 PW, and then I'm minusing that, so it turned into plus PW. And then the last, positive 1/4 W squared, but then I got to do opposite, so negative 1/4 W squared. Okay? All right. Looks like a mess, but actually it's not bad at all, because what happens? P squareds cancel, 1/4 W squareds cancel, and we end up with 2 PW. So, at the end of the day, we can rearrange here a little bit. Let's put the 2 in front with the pi. We have 2 pi PHW. That is the volume of that thing right there. Now, what we want to do is add up an infinite number of those. So what's going to add them? The integral. 2 pi will go out in front. pH. What happens to the W? Becomes the dx. Because it gets thinner and thinner and thinner, and then from wherever the strips fill the space from. Okay, and we'll write that formula on our other on the other page in a minute. That's it. It's a very simple little formula. And what did we say? Look right over here. Look what P and H are. P is, now we'll have to talk about that, but P is the distance from the axis to the strip. Now the way we'll get that is right minus left, and then the strip H is the height of the strip, top minus bottom. So actually, it's interesting in these problems. we will do both a right minus left and a top minus bottom, because P will be this direction and H will be this direction. And if we're revolving the other way, vice versa. Okay? Yes. Yeah. So let's go back to our formula, and I'll write that in here. So our shell method formula is 2 pi integral from A to B, whatever those numbers end up being, and then P times H dx, or it could be dy if we have horizontal strips. Remember, if you have horizontal strips, it's dy. If you have vertical strips, it's dx. And again, we should write down P is the distance from the center, which is your axis of revolution, to the strip. Now, that's going to be kind of the new part for us to find, but it's really easy once you get the hang of it. And H is the length of the strip, which is what we've been doing all along in all of these problems, right? The length of our strip has been our radius, or it's been our big R and our little r, or it's been our B, or it's been our diameter of our semicircle, or it's been our base of our equilateral triangle, or it's been one side of the square. It's going to be, right, it's this the length of the strip. So the really only new kind of thing we have to consider here is this thing called P, the distance from the center to the strip. But it's a very simple little formula. And now let's go ahead and let's do that problem we were just doing. And now let's do it this alternate way. So we have 3/28 pi over 15, which we did with horizontal strips. Okay? Everybody get copied down what they need to copy. All right, so let's go back to this problem right here. Same problem. Let's go ahead and draw our parabola. We got x equals 1 right here. We got x equals 4 right here. That's awful drawing. Okay, so we got x equals 1 right here. We got x equals 4, and we're going to revolve around x equals 5, like so. So we have this region. Okay, we're going to revolve around x equals 5. So if we're going to do the shell method, what direction are our strips? Right? If you got vertical axis of revolution or layers, we wrap around the vertical axis of revolution with vertical strips. They're always opposite of what they would be with the dishwasher method. And thus our earlier discussion, that's why this works better, because vertical strips are much nicer in this problem, because vertical strips allow us to just do one thing, okay? So what we have to do, though, is we have to write down what P is, and we have to write down what H is. Well, let's do H first, because H is what we're used to doing. H, remember, is the length of the strip. And so what is that going to be? Square root of x minus z. Top minus bottom. That's H, okay? By definition, H is the length of the strip. What is P? P is the distance from the center, which is the 5, to the strip. So that is this distance. Now, you don't have to draw that little squiggly line there, but I often do. It's the distance from here to here. Now, what is that distance? Well, let's imagine that that strip right now is setting at 3. Right? Let's imagine that strip is setting here at 3. How far is this distance? 5 minus 3, right? Which would be 2. Let's say that strip was setting over here at 2. What is this length? 5 minus 2, which would be 3. So in general, what is the length of that strip? 5 minus x. It's going to be that way every time. What I usually do when I write a strip like this is I put a little x underneath it. Now, if you had a horizontal strip, what do you suppose you'd write next to it? You'd write a y next to it. Okay? And P in this case is going to be this x coordinate, 5, minus this x coordinate, which we don't know. It's x. So 5 minus x. Now, let me give you a little hint about p. And this is the part that sometimes people get confused on because you make it way, way too hard. P will always be 5 minus x, 2 minus x, negative 3 minus x minus 1, x minus 0, x minus a negative 2. Always, always, that's what p will be. And if they're horizontal strips, p will be y minus 1, 2 minus y, 3 minus y minus a negative 2. Always, that's always what p will be. If you have a square or a square root or a sine or something in p, you're doing it wrong. P will always look like this, always. H will have the functions in it. Okay, so you just label the strip and you do a right, and it's always from the center. Now you might say, how come it would be 5 minus x one time and another time it might be x minus 5? Well, what if our region would have been over on this side? Then our x, our strip, would have been over here. And the distance from here to 5 is right minus left. It'd be x minus 5. But here the strip is to the left of our axis of revolution, so it's 5 minus x. It's always right minus left. It's always right minus left. Now here you get in trouble. Remember we were talking about how if you do it backwards on the other ones, you're okay? Because we always squared them. Well, here if you have them backwards, you get a wrong answer. Well, now what you get is a negative. And if you get a negative volume, you know you did it wrong. Now, it's probably the right answer. You just take off the negative. But that tells you probably have this backwards. Okay? All right. So there you go. So what's our integral then going to be? 2 pi out in front. Don't forget the 2 pi. And then 5 minus x. Doesn't matter what order. I usually do p then h. Square root of x. dx from the strips fill the space. Same thing we've always preached. The strips fill the space from 1 to 4. Now, you see why the empty space doesn't matter in a shell method. How did we take care of the empty space? We only went from 1 to 4. What if there was no empty space? What if this region went all the way to the 5? Then our integral would have went 1 to 5. You see how that takes care of the empty space? We only do the integral from the part where the strips are in, the solid part. So we don't have to worry about the empty space, which is another nice method. Another nice thing about the shell method is it just takes care of itself. And if you type that in, I'm pretty sure we checked it in the other class. You type that in, you're going to get that same answer, 328 pi over 15. So once you get the hang of this, look how much less work that was than the one we did earlier. Okay? So, now sometimes shell method is not going to be that much of an advantage. Okay? Sometimes it's about a 50-50 deal. So then it's just kind of up to you which one you like better. To be honest, sometimes people like shell method better. Let's do this one more and let's just look at one where that is the case. So let's take here, let's take y equals x squared. It says in the first quadrant, here's a line x equals 2. What would this point be up here? 2 what? 2, 4. And we're going to revolve around y equals 4. Now, let's look at both of our techniques that we now know about. We'll do both of them. We'll do both on this one. This is a type of problem where I said that a lot of times on the quiz, people will do both ways and check it. I think on your homework it might ask you maybe sometimes to do it both ways. I'm not sure. Okay, we got a horizontal axis like this, y equals 4. So, shell method, which way the strip's going to be? If we do shell, horizontal, parallel, right? Like this, horizontal strip. Which way if we do dishwasher? Vertical. Is there empty space or not? Let's do that one first. Okay, let's do the one with empty space. Okay, vertical strip. So that would be a big R, and that would be a little r. Right there. Now remember, there's oftentimes, I mean, some of you might be thinking, oh, I like this one better. I've never understood this washer. I'll just use shell all the time. Well, it's not like you can really do shell all the time. Or if you can, but it's more difficult if you do shell. You know, so you can't think that, oh, he's just showed us a better way. You know, on some problems it might be. Okay? But this one's not bad. What's big R on this one? 4 minus 0. What's little r? 4 minus x squared, right? So we don't have to do any square rooting or any solving anything. So that's not bad. That's pi. The integral would go from what to what? 0 to 2. And then we got big R squared minus little r squared. Come on. Dx, right? 4 minus x squared, squared, so big R squared minus little r squared, strips fill the space from 0 to 2, okay? There we go, right? And we can get that in, Cody? Okay, we'll see what that is. Now, let's do shell. Shell, we said, was what? What kind of strips? Horizontal strips. So, we got this strip here. Now, H, remember, is always in the region. We don't have to worry about to the center. H is just the strip in the region every time. H is in the region every time. Okay? So that's going to be H right there. So what is H going to be? Two minus, this is H we're doing now. Not the P, H. This x coordinate minus this x coordinate. What's this x coordinate right here? Square root of y. We got to do the square root, right? And plus or minus, but the plus would be the right half, and that's what we have is the right half. So 2 minus square root of y. So remember, H is our normal way of doing business. H is our strip in the region, okay? It's always in the region, is H. 2 minus square root of y. And then what's P? What did we say? We would label this strip what? With a y. And then what's P? P is from where to where? P is from where to where? Look in your notes. P is from where to where? From the center to the strip. Where's the center? 4. That's this distance right here. I usually draw that in there. It's from the center to the strip. P, you gotta get that into your head. P is from the center to the strip. So what is that going to be? 4 minus y. 4 minus y. It's got to be a y, right? 4 minus y. Top y value 4 minus bottom y value, which is just y. We don't know where that strip is. It could be anywhere in there. So it's just y. So it's 4 minus y. Remember, P will always look like this. P will always look like this. Not H. P will always look like this. Okay? So, 4 minus y. So what do we got? We got 2 pi integral. The integral is going to go from what to what? 0 to 4. And then P, 4 minus y, H, 2 minus square root of y, dy, and type that in, and hopefully, Cody, you get the same answer. What do you get? 224 pi over 50. Okay? On your assignment sheet, it's the last LH line. The last LH line, the one that's page 427, got 5 problems. 4, 9, 12, 17, and 21. Might be a couple of those have maybe more than one problem in them, but 427, the last LH line, 4, 9, 12, 17, and 21. Okay? Now, I do believe, let me just look real quick. LH. Okay, they all say use the shell method, 4, 9, 17. Now, on 20, what are the last two? On 21. 21 has 4 parts, and it says use the disk or the shell method to find the volume. So you have your option, whichever you think is easier. But on the first 4, you are supposed to use the shell method. Okay? And then on 21, on those in that section, you use whichever one is best. Okay? All right, I'm going to go ahead and give the 2015 to everybody here, so bring that with you tomorrow. If you're not going to be here, obviously you want to do some work in that. Mrs. Linder asked. Mrs. Payne's mother passed away. few days ago down in Oklahoma, so.
My life's in this. Look at that.
Yes, because obviously since the thing is still hanging there, no one else must be in the bathroom.